Welcome to Hadoop Ecosystem. My name is Richard Kirshner with the Simplilearn team. That's www.simplilearn.com. Get certified, get ahead. Today we're covering the Hadoop ecosystem, at least the very fundamentals of all the different parts that are in the Hadoop ecosystem. And it's very robust. It's grown over the years with different things added in. There's a lot of overlapping in a lot of these tools, but we're just going to cover these basic tools so you can see what's available in the Hadoop ecosystem. So let's go back to our Hadoop ecosystem. As you can see, we have all our different setup, and let's focus on the Hadoop part of it first before we look at the different tools. We start with the Hadoop, or HDFS, is for data storage. Write once, read many times, you can store a lot of data on it affordably. Distributed file system. And so when we talk about the Hadoop file system, it stores different formats of data on various machines. And so you have like a huge cluster of computers and you're able to store Word documents, spreadsheets, structured data, non-structured data, semi-structured. And in the Hadoop file system, there's the two different sets of servers in there. There's the name node, which is the master. We talked about that. That's your enterprise computer. And the other component is your data nodes. And so you'll usually have, like I said, 1 to 2. You'll have a name node and maybe a backup name node. And then you'll have as many data nodes as you want. And you can just keep adding them. That's what makes it so affordable. You know, you have a rack of computers and you go, oh, I need more space. You just add another rack in. So it's very affordable and very easy to expand. And the way the Hadoop file system itself works behind the hood is it splits the data into multiple blocks. By default, it's 128 megabytes. And the 120 megabytes, it is a default setting. You can change that. That works for most data. There's reasons for either processing speed or for better distribution of the data. So if you have little tiny blocks of data that are less than 128 megabytes, if you have a lot of those, you might want to go down in size, and vice versa for larger blocks. And you can see right here we have 300 megabytes, and it takes that piece of data and it just divides it into blocks of data, and each one's 128, 128, and 44, which if you add together equals 300 megabytes. And now that you understand the Hadoop file system, or at least the basic overview of it, it's important to note what it sits on, what's actually making all this work on the back end. And this is Yarn. Hadoop Yarn is a cluster resource management. So it's how it manages this whole cluster right here that we just looked at. And Yarn stands for Yet Another Resource Negotiator. Love the title. It reminds me of an Iron Man movie with Tony Stark's and Jarvis. Just a rather intelligent system, or whatever it stood for. But Yarn has become very widely used, and it's actually used as a backend for a lot of other packages. So it's not just in Hadoop, but Hadoop is where it came from and where it's set up. And there's some other ones. Another popular one is Mesos, which I'll mention again briefly. And so the Yarn, it handles the cluster of nodes. It's the one, when you hear Yarn, it's the one that's going, hey, where's our RAM at? Where's our hard drives at? Or if you have a solid state disk drive, your SD, where's that at? How much memory do I have? What can I put where? And so here we go. Nice image of it, RAM, memory, resources. So it's allocating all these different resources for different applications is what it's doing. When we talk about back to the two major components, the two major components is your resource manager. That's on the master server or your enterprise computer, and then that one is in control and managing what's going on with all of your nodes. Data processing in Hadoop, MapReduce. And we're going to talk about the MapReduce here in just a second. The Hadoop data processing is all built upon MapReduce. MapReduce processes a large volumes of data in parallelly distributed manner. And this is very core to Hadoop. But before we go on, because there's other tools out there and things are slowly shifting and there's all kinds of new things, one of the things you want to look at is not just how the MapReduce works, but start thinking MapReduce. One of the best pieces of advice I had from one of my mentors in data science was think MapReduce. This is really what you should be learning. But it is an actual process in the Hadoop system. So we have our big data, and the big data maps out. And so this is the first step, is if I'm looking at my data, how do I map that data out? What am I looking at? And it could be something as simple as I just load it into, I'm just looking at one line at a time. But it could be that I'm looking at the data one line at a time, but I only need columns 1 and 4. Maybe I'm looking at it one column at a time, but I need the total of column 1 added together and column 1 over column 2. So you can start to see and get some very complicated mapping here, but the mapping is what do you do with each line of data? each piece of data. If you're in a spreadsheet, it's easy to see you have a row. Whatever you do to that row, that's what you're mapping, because it doesn't look at anything else, it doesn't know anything else, all it knows is what's on that row. If you're looking at documents, maybe it's pulling one document at a time, and so your map is then a document. And then it takes those and we shuffle and sort them. How do we sort them around? Whether you're grouping them together, whether you're taking the whatever information you mapped out of it. Word counts, you're counting the word A, so letter A comes out with how many for each mapping. If you have 54 A's per the one document, 53 in the other ones, that's what's coming out of that mapping and going into the shuffle and sort. And so if it's counting A's and B's and C's, it'll shuffle and sort all the A's together, all the B's together. If you're running a big data for running agriculture, apples and oranges, so it puts all the apples in one, all the stuff you mapped out that you said, hey, these are all apples, these are all oranges, let's shuffle them and sort them together. And then we reduce and reduce. So each of these groups reduce into the data you want out. So you have map, shuffle, sort, reduce. And some important things to know about the Hadoop file system, because I'm going to mention Spark in a little bit, is the Hadoop file system manages to do a lot of this by writing it to the hard drive. So if you're running a really low budget, which nobody does anymore with the Hadoop file system, and you have all your commodity machines are all low, they only have 8 gigabytes memory instead of 128 gigabytes. This process uses the hard drive, and so it pulls it into the RAM for your mapping. It maps a one piece of data, then it writes that map to the hard drive. Then it takes that mapping from the hard drive, loads it up, and shuffles it and writes it back to the hard drive to a different spot, and then takes that information and starts processing it in the reduce, and then it writes the reduce answer to the hard drive. It runs slower because you're accessing to and from your hard drive or solid state drive if you have an SD card in there. But you can also utilize, it's a lot more affordable. You know, it's like I said, you having that higher end of RAM cost even on a commodity machine, so you can save a lot of money. Nowadays, it's so affordable, people run the Spark setup on there, which does the same thing but in RAM. And again, we'll talk about Spark in just a little bit. And of course, the final thing is an output. So again, your reduce are written to the hard drive, and then your reduce is brought together to form one output. What is the maximum number of oranges sold per an area? I don't know, I'm making that up. One of the things about Hadoop is it covers so many different things that anything you can think of, you can put in Hadoop. The question is, do you need to? Do you have enough data or enough need for the high-end processing? So again, look at MapReduce, but think of this not just as MapReduce. Start thinking map and reduce when you think big data. We're going to start getting into the tools, because you had all those pictures of all those cool tools we have. So we're going to look at the first two of those tools. And in the tools we have Sqoop and Flume, and this is for your data collection and ingestion. We're going to bring Spark up in just a second. Can also play a major role in this, because Spark is its own animal that's sprung from Hadoop, connects into Hadoop, but it can run completely independent. But Sqoop and Flume are specific to Hadoop, and they're ways to bring in information into the Hadoop file system. And so when we talk about these, we'll start with Sqoop. Sqoop is used to transfer data between Hadoop and external data stores, such as relational databases and enterprise data warehouses. And so you can see right here, here's our Hadoop data, and it's connecting up there, and it's either pushing the data or pulling the data. And we have our relational database and enterprise data warehouse. And there's that magic word, enterprise. That means these are the servers that are very high end. So maybe you have a high-end SQL server or a MySQL server or whatever over there. And this is what's coming and going from the Sqoop. It imports data from external data stores into the HDFS, Hive, and HBase. Those are our two specific. The Hive setup is your SQL, basically. And you can see a nice little image here. Here's somebody on their laptop, which would be considered the client machine, putting together their code. They push the Sqoop. The Sqoop goes into the task manager. The task manager then goes, hey, what have I got for the HBase and Hive system in our Hadoop system? And then it reaches out to the enterprise data warehouse or into the document-based system or relationship-based database. Relationship is your non-SQL. Document is just what it sounds like, is you have HTML documents or Word documents or text documents, and it's able to map those tasks and then bring those into the Hadoop file system. Now, Flume is a distributed service for collecting, aggregating, and moving large amounts of log data. So kind of focused a little bit on a slightly different set of data, although you'll find these overlap a lot. You can certainly use Flume to do a lot of things that you can do in Sqoop and vice versa. Flume ingests the data, so we're looking at, like, say, a JSON call to a website. XML documents, unstructured and semi-structured data is most commonly digested by Flume. Best example I saw saw was a Twitter account pulling Twitter feeds into a Hadoop system. So it ingests online streaming data from social media, Twitter, log files, so we want to know what's going on with error codes on your servers and all those log files, web server, what's going on in your web server. We can bring all this stuff in and just dump it into the Hadoop data file system to be looked at and processed later. And it's a web server, cloud, social media data. Again, all those different sources it can be. It's kind of endless. It just depends on what your company needs. Versatility of Hadoop is what makes it such a powerful source to add into a company. And so it comes in there, you have your source, it goes through the channels, it then goes through kind of a sync feature to make sure everything is in sync, and then it dumps it into the Hadoop file system. So we've covered in the Hadoop file system the first two things. Let's look at some of the scripting languages they have. And so we have the two here, and you can also think of these, it actually says scripting and SQL queries. A lot of times they're both referred to as queries. So you have both the Pig and the Hive. And Pig is used to analyze data in Hadoop. It provides a high-level data processing language to perform numerous operations on the data. And it's made out of Pig Latin, language for scripting. Pig Latin compiler converts Pig Latin code to execute code. And then you have your ETL. The ETL provides a platform for building data flow for ETL. And ETL is like the catch, 3 letters now on any job interview I look at. It says ETL. It just means extract, transfer, and load. So all we're doing is extracting the data, transferring it to where we need it, and then loading it into, in this case, a Hadoop file system. And there's other pieces to that. It's actually a big thing because whenever you're extracting data, do you want to dump all the data, or do you want to do some kind of pre-processing so you're only bringing in what you want? And then one of the cool things about Pig Latin is 10 lines of Pig Latin script is around 200 lines of MapReduce job. Again, the MapReduce is the back-end processes that go on. And so if we have Pig, and I'll be honest with you, Pig is very easy to use, but as a scripter programmer, I find it's more for people who just need a quick pull of the data and able to do some very basic things very easily. So if you're doing some very high-end processing and model building, you usually end up in something else. So Pig's great for that. Like if you're in the management, you need to build a quick query report, Pig is really good for that. And so it definitely has its place. It's definitely a very useful script to know. And the Pig Latin scripts, they call it the grunt shell. I guess it goes with Pig because they grunt. You have your Pig server. You have a parser, an optimizer, a compiler, an execution engine. And that's all part of the Apache Pig. And this then goes into the MapReduce, which then goes into the Hadoop file system in the Hadoop. And you'll see Apache with a lot of these because it's under the open source. Hadoop's under the Apache open source. So all this stuff is you'll see under Apache with the name tag on there. And if you're going to know Pig, Hive is the other one that's really popular for easy query. Hive facilitates reading, writing, and managing large data sets residing in the distributed storage using SQL, Hive query language. And this is important because a lot of times you're coming from an SQL server. There's your enterprise set up, and now you're archiving a history of what's going on that server. So you're continually pulling data using Sqoop onto your into your HBase, Hive database. And as it comes in there, it'd be nice to just use that same query to pull the data out of the Hadoop file system. And that's exactly what it does. So you have Hive command line. You can also use a JBC or ODBC driver. And those drivers, like if you're working in Java or you're working in Python, you can use those drivers to access Hive. So you don't have to go through the Hive command line. But it makes it real quick. I can take a Hive command line and just punch in a couple words and pull up my data. And so it provides user-defined functions, UDF, for data mining, document indexing, log processing, again, anything that is in some kind of SQL format. If it's stored that properly on the Hadoop file system, you can use your Hive to pull it out. And you see even a more robust image of what's in the Hive. There's your client machine, that's you on your laptop or you're logged in wherever you're at, writing your script. That goes into the driver where you have your compiler, your optimizer, executor. You also have your JDBC, ODBC connections, which goes into the Hive Thrift server, which then goes into the driver. Your Hive web interface, so you can just log in on the web and start typing away your SQL commands, and that again goes to the driver and all those pieces. And those pieces go to your job tracker, your name node, and your actual Hadoop file system. So Spark, real-time data analysis. And I told you Spark is its own animal. So we're going to touch very little on Spark as far as how big and robust it is. But we're going to talk a little bit about Spark. Spark is an open source distributed computing engine for processing and analyzing huge volumes of real-time data. So it runs 100 times faster than MapReduce. MapReduce is the basics of the Hadoop system, which is usually set up in a Java code. In Spark, the MapReduce, instead of running, what happens in MapReduce is it pulls it into the RAM, writes it to the hard drive, reads it off the hard drive, shuffles it around, writes it back to the hard drive, pulls it off the hard drive, does its processing, and you get the impression it's going in and out of RAM to the hard drive and back up again. So if you don't have a lot of RAM and you have older computers and you don't have the RAM to process something, then Spark and Hadoop are going to run the same speed. Otherwise, Spark goes, hey, let's keep this all in the RAM and run faster. And that's what we're talking about, is provides in-memory computation of data. So it's fast. You can see the guy running through the door there. Speedy versus very slow Hadoop wandering around. It is used to process and analyze real-time streaming data, such as stock market and banking data. So the Spark can have its own stuff going on, and then it can access the Hadoop database. It can pull data just like Sqoop and Flume do. So it has all those features in it. And you can even run Spark with its own Yarn outside of Hadoop. There's also Spark on Mesos, which is another resource manager, although Yarn is most commonly used. And currently Spark pretty much comes installed with Hadoop. And so your Spark running on top of Hadoop will use the same nodes. It has its own manager, and it utilizes the RAM. So you'll have both. You can have the Spark on top of there. And here we go. You have your driver program, your Spark context. It goes into your cluster manager, your Yarn. Then you have your worker nodes, which are going to be executing tasks and cache. And it's important to remember when you're running the Spark setup, even though these are commodity machines, we're still usually, a lot of them are like 128 gigabytes of RAM, so that Spark can run these high-end processes. Certainly if it's not accessed very much and you're building a Hadoop cluster, you could drop that RAM way down if you're doing just queries without any kind of processing on there, and you're not doing a lot of queries. But generally Spark, you're looking at higher end. They're still commodity machines to do your work. And now we get into the Hadoop machine learning. And so machine learning is its own animal. I keep saying that. These are all kind of unique things. Mahout is being phased out. I mean, people still use it. It's still important. If you can write your basic machine learning that has most of the tools in there, you certainly can do it in Mahout. Mahout, again, writes to the hard drive, reads from the hard drive. You can do all that in Spark, and it's faster because it's just in RAM. And so Spark has its own machine learning tools in it. And you can also use PySpark, which then accesses all the different Python tools, and there's just so many tools you can dump into Spark. Mahout is very limited, but it's also very basic, which in itself can be really good. Sometimes simple is better. So Mahout is used to create scalable and distributed machine learning algorithms. So here we have our Mahout environment. It builds a machine learning application. So you're doing linear regression, you're doing clustering, you're doing classification models. It has a library that contains inbuilt algorithms for all of these, and then it has collaborative filtering. And again, there's our classification and there's our clustering. Regression, so you have your different machine learning tools. We can easily classify a large amount of data using Mahout. So this brings us to the next set of tools we have, or the next tool, which is the Apache Ambari. Ambari is an open source tool responsible for keeping track of running applications and their statuses. Think of this as like a traffic cop, more like a security guard. You can open it up and see what's going on. And so the Apache Ambari manages, monitors, and provisions Hadoop clusters, provides a central management service to start, stop, and configure Hadoop services. So again, it's like a traffic cop. Hey, stop over there, start, keep going. Hey, what's going on over that area in the through lane on the high-speed freeway? And you can open this up and you have a really easy view of what's going on. And so you can see right here you have the Ambari web. The Ambari web is what you're looking at. That's your interface that you've logged into. The Ambari server, this will be usually on the master node. It's usually, if you're going to install Ambari, you might as well just install it on the same node. And it connects up to the database, and then it has agents, and each agent takes a look and see what's going on with its host server. And if you're going to have 2 more systems, and we talked about Spark streaming, there's also Kafka and Apache for streaming data coming in. And Kafka is a distributed streaming platform to store and process streams of records, and it's written in Scala. Builds real-time streaming data pipelines that reliably get data between applications. Builds real-time streaming applications that transforms data into streams. So it kind of goes both ways on there. So Kafka uses a messaging system for transferring data from one application to another. So we have our sender, we have our message queue, and then we have our receiver. Pretty straightforward, very solid setup on there with the Kafka. Apache Storm. Storm is a processing engine that processes real-time streaming at a very high speed, and it's written in Clojure. They utilize the function-based programming style of Clojure, and it's based on Lisp, to give it the speed. That's why Apache Storm is built on there. So you could think of Kafka as a slow-moving, very solid communication network, where Storm is looking at the real-time data and grabbing that streaming data that's coming in fast. So it has the ability to process over 1 million jobs in a fraction of seconds on a node. So it's massive. It can really reach out there and grab the data. And it's integrated with Hadoop to harness higher throughputs. So this is the 2 big things about Storm. If you are pulling, I think they mentioned stock coming in or something like that, where you're looking for the latest data popping up, Storm is a really powerful tool to use for that. So we've looked at a couple more tools for bringing data in. We probably should talk a little bit about security. Security in Hadoop has the Apache Ranger and Apache Knox are the 2 most popular ones. And the Ranger, the Apache Ranger is a framework to enable, monitor, and manage data securities across the Hadoop platform. So the first thing it does is it provides centralized security administration to manage all security-related tasks. The second thing it does is it has a standardized authorization across all Hadoop components. And third, it uses enhanced support for different authorization methods, role-based access control, attribute-based access control, etc. So your Apache Ranger can go in there, and your administrator coming in there can now very easily monitor who has what rights and what they can do and what they can access. So there's also Apache Knox. Knox is an application gateway for interacting with the REST APIs and the UIs of Hadoop developers. And so we have our application programmer interfaces, our user interfaces, and we talk about REST APIs. This means this is looking at the actual data coming in, what applications are going on. So if you have an application where people are pulling data off of the Hadoop system or pushing data into the Hadoop system, the Knox is going to be on that setup. And it delivers 3 groups of user-facing services. 1, proxy services, provides access to Hadoop via proxying the HTTP request. 2, authentication services, authentication for REST API access and web SSO flow for user interfaces. So there's our REST. And finally, client services. Client development can be done with the scripting through DSL or using the Knox shell classes. So the first one is if you have a website coming in and out, your HTTP request. Again, your 3 different services are what's coming in and out of the Hadoop file system. So there's a couple of the security setups. Let's go ahead and take a look at workflow system, the Oozie. And there's some other ones out there. Oozie is the one that's specific to Hadoop. There's also like a Zookeeper out there and some other ones. Oozie's pretty good. Oozie is a workflow scheduler system to manage Hadoop jobs. And so you have a workflow engine and a coordinator engine. So it consists of 2 parts, what's going on and coordinating what's going on. And directed acyclic graph DAGs, which specifies a sequence of actions to be executed. These consist of workflow jobs triggered by time and data available. And if you're not familiar with directed acyclic graphs or DAGs or whatever terminology you want to throw at this, this is basically a flow chart. You start with process A, then the next process would be process B when process A is done. And it might be that process C can only be done when process D, E, and F are done. So you want to be able to control this. You don't want it to process the machine learning script and then pull the data in that you want to process it on. You want to make sure it's going in the right order. So these consist of workflow jobs, and they're triggered by time and data availability. So maybe you're pulling stocks in the middle of the night, and once the stock is all pulled, so there's our time sequence. It says, hey, they've been posted on the other websites. They post them usually after the stock market closes, the highs and lows and everything. Then once that data has been brought in, on a time specifics, bring the data in at a certain time. Once the data is available, then we want to trigger our machine learning script for what's going to happen next. And so we can see here we have start, our MapReduce program, our action node, and it begins, and either we have a success, then we notify the client of success, usually an email is sent out, in successful completion. Or we don't have a success, we have an error, notify client of error, email action node, kill unsuccessful, termination. And usually at this point they say email action notification, but that's usually a pager system, and so you see all the tech guys running to the server room or wherever, where our pager just went off. We got to figure out what went down. The other one is you just look at the next morning, you go, oh, well, let's make sure everything went through this morning and check all your successes. With the error, usually it's sent to your pager and your emergency call to open up in the middle of the night and log in. So that concludes our basic setup with the Hadoop ecosystem. So a quick recap on the Hadoop ecosystem. We covered looking at the middle part. We had the Hadoop as a file system and how it stores data across multiple servers. Saves money because it's about 1/10 of the cost of using enterprise computers. We looked at Yarn, cluster resource management, and how that works to hold everything together. And then we looked at a lot of data processing. How does it process in and out of the Hadoop system, including the MapReduce setup, which is the Hadoop basic in Java. And for that, we looked at data collection and ingestion with Sqoop and Flume. We looked at queries using the scripting language Pig and the SQL queries through Hive. We glanced at Spark. Remember, Spark usually comes installed now with the Hadoop system because it does so much of its own processing. It covers a lot of the data in, real-time data analysis setup on there. We looked at Mahout, machine learning. We looked at Apache Ambari for management and monitoring, kind of your security guard and traffic control. Just like we have Sqoop and Flume, which brings data in there. We looked at Kafka and Apache Storm, which is for streaming data. And then we looked at Apache Ranger and Apache Knox for security. And finally, we took a glance at Oozie for your workflow system. So thank you for joining us today. For more information, visit us at www.simplilearn.com. You can also feel free to add notes on the YouTube video because we do monitor that. Feel free to like and share our posts because that is how we build our community and grow to bring you more content and better setup and more information. Again, my name is Richard Kirshner with the Simplilearn team, www.simplilearn.com. Get certified, get ahead.
Hi there, if you like this video, subscribe to the Simplilearn YouTube channel and click here to watch similar videos. To nerd up and get certified, click here.